Well, welcome to Chapter 2. We are going to be talking about the rectangular coordinate systems and graphs. And this is also called the Cartesian coordinate system. So here are your learning targets. I'm going to zip through some of this pretty quickly because I think most of this should be review for you from Algebra 1. So we have what we call the Cartesian coordinate system, and it's based on a two-dimensional plane where we have our x and our y-axis, and they are perpendicular to each other. The y-axis is vertical, the x-axis is horizontal. They divide the plane into 4 quadrants that are numbered counterclockwise, and in the center we have the origin, and the coordinates of the origin are 0, 0. Now any point that we have in the coordinate plane is identified by its x and y coordinates, and we call those coordinates an ordered pair, and we represent those in parentheses with a comma between them. So one of the things you're going to need to be able to do is to not only graph ordered pairs, excuse me, but to be able to graph equations by plotting points. So if you're given any equation like y equals 2x minus 1, you can pick values for x. X is called the independent variable. We choose those values randomly, and then we calculate what the outputs are going to be for y. So if you plug in those x values, these are the y values you get, and then you can go ahead and plot those points. So we have here's 0, negative 1, there's another point, there's 1, 3, negative 7, and then going in the positive direction, we have these points as well. I think that's all of them, yep. So then we can connect those dots together to form a line, and you should always get a straight line for a linear equation, and it should look something like that. Now, one of the other things that I would like you to be able to do, you need to use your graphing calculator. We will be using technology tools to do this, and so I'm going to give you a little video here on how to use your calculator to go ahead and graph linear equations. So here we go.
All right, so in this screen we're going to talk about how to use your graphing calculator. And this is a picture of the TI-84 Plus edition, so yours should be very similar. So the first thing you need to do is turn it on, and hopefully you've already learned how to do most of those kinds of basic things. And let's go ahead, in the last slide we talked about how to find the x and y intercepts. So I'm going to show you how to put the equation into your calculator and then have it just graph. So in order to graph an equation, it has to be solved for y. So you have a button up here where it says y equals. You want to touch that, and it brings up a whole bunch of y equals equations, and they're all blank. They should be all blank. One of the things to check for first is these stat plots up here, plot 1, 2, and 3. None of those should be blackened in. If you have one that's blackened in like that, what you want to do is just move your arrow key up there and hit enter, and that selects and deselects. So I just selected it, so you'll notice if I come back down, see how that's blackened in. We want those stat plots to be turned off. So if you don't have, and actually some of the newer TI-84s, you don't have to worry about that, but I just wanted to show you, if you happen to have an older calculator like mine, that's kind of what it would look like. So we want those not selected. Let's go ahead and use the same equation that we graphed in our previous example, y equals 2x minus 1. So we already have the y equals. We're going to use y1, and so we need the number 2, so just put a 2. Now your x variable is right here. It's xt theta n, so you want to press that button and it'll put an x for you. And we need minus 1, so just hit minus 1. Now to graph this thing, what we're going to do is just hit our graph button. And usually we'll get a standard viewing window where it's 10 by 10. And you can set your window. If you press the window button, it shows you what your minimum and your maximum on your x and y axes are. And then this is a scale factor. And resolution you can ignore. That'll always be 1 for our purposes. You can also set a standard viewing window right here. If you go into the zoom and choose option 6, that's our standard viewing window, which is the 10 by 10. Okay, so that's how we graph it on the calculator. We're also going to be talking about finding our intercepts. That's coming up in the next couple of slides here. So I'm going to go ahead and show you how to do that on your calculator here. So if we want to find the intercepts, we're going to use this calculate, which is a second function. So I'm going to hit second trace, which is the calculate. The value for option 1, since option 1 is selected, I'm just going to hit enter. And I want to know what happens when x is 0. And if I hit enter again, it tells me right here that y is -1. So I have just found when x is 0 what my y-intercept is. Similarly, I could go ahead and do second calculate, that second trace, and find what's called a 0. This tells me where it crosses the x-axis, and this asks me left bound, right bound, and guess. So if you just hit enter for your left bound, and then move it to the right a little, you'll see this scrolls onto your graph here, and then hit enter, and then hit enter again. And that tells me when y is 0, x is 0.5, so my x-intercept is 1/2. So that's it for this slide.
All right, so there you have it. I need to get rid of the calculator here. So to find the x and y intercept using algebra, those are basically just points where the graph crosses the axis, the x or y axis, and the x-intercept is where the graph crosses the y-axis, or excuse me, the x-axis, and at that point y is equal to 0. So that's how we find it, by setting y equal to 0. The y-intercept tells us where the graph crosses the y-axis, and similarly you're going to do the opposite and let x be 0. So to find the x-intercept, set y equal to 0, solve for x. To find the y-intercept, set x equal to 0, solve for y. So that's how you find the intercepts algebraically. So here we go. Here's an example. We have the equation y equals 3x minus 1. So to find the intercept, what we want to do is set y equal to 0 to get the x-intercept. And we're going to go ahead and do that. If we let y equal 0 right here on the left, we get 0 equals 3x minus 1, add 1 to both sides and divide by 3, and we end up with x equals 1/3 as our intercept. And so we want to represent that as an ordered pair where x is 1/3 and y was 0. To find the y-intercept, we're going to let x equal 0. So when we let x equal 0, the x term drops out, and very quickly we get y equals -1. So that represents the ordered pair 0, -1. So those are our two intercepts. I have a note here for you. We can verify those results using the graphing calculator. So if you want to punch that equation into your graphing calculator, y equals 3x minus 1, just like I showed you in the video on the last slide, you can verify that those are the correct intercepts using your calculator. That'd be good practice for you. Another note I have here for you is finding the intercepts is another way that we can sketch the graph. Rather than randomly putting in values for x, we could just find our two intercepts. We only need 2 points to graph a line, and that would allow us to go ahead and graph the line as well. Using the distance formula is used to find the distance between 2 points. It's basically an application of the Pythagorean theorem, which you hopefully recall as a squared plus b squared equals c squared. And that's based on a right triangle where A and B are the lengths of the legs and C is the length of the hypotenuse. So what we're talking about here, A and B are the legs. Those are the two sides that include the right angle. And then the hypotenuse is the side opposite the 90-degree angle. Hopefully that's review for you as well from geometry. So in general, if we have any 2 points, x1, y1, and x2, y2, we can find the distance between those two. And the way that we're going to do that is using the distance formula, where we take x2 minus x1 square it, y2 minus y1 square it, and take the square root. All that's finding is the length of these legs. When you take x2 minus x1 right here, you're finding the length of this leg. So you're going to take that leg squared plus this leg squared equals this leg squared. It's just the Pythagorean theorem. Here's an application for you. 2 points, -3, -1, and 2, 3. Find the distance. So we're going to plug that into our formula. We're going to let the first point be x1, y1, and the second point be x2, y2. So we're going to take x2, which is 2 minus a minus 3, square it, and then take 3 minus a minus 1 and square it. When we get that, we get 5 squared plus 4 squared, which gives us 25 and 16, which is a total of 41, and we take the square root of that. Okay, so most of the time you can leave your answer in radical form or write a decimal. I'll usually tell you what I want in your answer. We also have the midpoint formula. If we have 2 points, 2 endpoints, and we know the endpoints, we can find the point that's exactly in the middle of those 2 points. That is called the midpoint, and we use the midpoint formula. And we start with those coordinates of the 2 endpoints. And basically all the midpoint is the average of the 2. So we're going to add the 2 x coordinates and divide by 2, and then add the 2 y coordinates and divide by 2. Here's a specific example for you. So we have x1, y1, x2, y2. So we're going to add 7 and 9 and divide it by 2. And then we're going to add negative 2 plus 5 and divide that by 2. So we get 16 divided by 2, which is 8, and 3 divided by 2, which is 3 over 2. Thought I had another thing in here. I guess I don't. Another application of the midpoint formula is to use it to find the center of a circle. So here I have an example for you where I give you the diameter of a circle with its endpoints. And the problem says to find the center using those endpoints. Well, if you remember, the diameter is the distance across a circle. So that if we found the midpoint here, that would be the center, right? So we'll go ahead and plug those into the midpoint formula, and we end up with coordinates 2, negative 4. So pretty easy. And then I have a couple of problems for you to do. Please work on these 3 and bring your answers to class. See you next time.